All right. Welcome again, everyone. I see Prosper, Raymond, Yola, Buki, Manuel, Bobby, and Bolaji. I think there's still a few more of us that should be here. Please, if you know any of your colleagues are supposed to be here, you can just give them a nudge. Share a message would have been sent in the Slack channel, some notification to remind them. But yeah, because of time, we would get started. And I want to get some feedback from us regarding our last class in terms of anyone that has tried out stuff that we learned. So if you remember, we talked about Kubernetes and container orchestration. We spoke about the Kubernetes architecture, etcd, API server, scheduler, manager, that proxy, all these different things explained about the control plane, the API server, scheduler, and the rest. So I just want to get some feedback, especially regarding the practicals. Did anyone try anything out? Do you have any question from the last class? I think that's the major thing. Anything you are not clear on that you would like me to speak on before we just dive into this session? Yeah, anyone? Anything? Any questions? Okay, I see Lika has one. Is there anybody else? It's just one. Okay, we'll just take Lincolns for now. Still have other times, that periods that are available for you to ask questions. So, Lincoln, please go ahead with your question.
Good evening and happy weekend.
Good evening.
Yeah, my
Yeah.
question is I was trying to run kubectl, like trying to run Kubernetes on Docker. So I was trying to do that. Then I will have a master container if I'm right. Then I will have the
Master
working
node,
one. Man got
water
like
nodes.
master
Yeah.
node. Then yes. Then I will need to have some pods. Hope I'm still yes, right? So now that
Yeah.
takes me back to Docker. So now I realize that without the basic knowledge of Docker, you can barely do so many things on Kubernetes. So now the question is just, why? Because all this thing we've been doing is we are just coming to do this thing. We are doing it, and you do it, you left it there. So I want to have an overview. Like, when do you need to create a container, and when do you need to create we still have a Docker image and a Docker. So I think I don't even know where all these things are taking me to. Now I know I can run Kubernetes on pods, then I can do some load balancing. This is what I did, trying to. I was just being trying to be audacious. But now, can you help me? When do you think we should create container, then Docker file, then images? Do you understand what I want to have a picture, like in a project, just a run through in a project. How do we start so we can merge Kubernetes into it? So I won't be having scattered knowledge. So thank you so much.
Okay, that's a brilliant question. It's always great to have an overview of what you're learning and how it should be useful to you in a project. So Docker, as we've learned, is a container runtime, right? It's able to work on its own, like we've demoed in the past. You're able to create containers and you're able to run your application on those containers. But one of the things you notice with Docker containers, which I've mentioned in the past, is um, there is there's no scalability when you're just running like a single Docker container. You're running containers individually, but you don't have any form of scalability. And that means if I run one container in a project and maybe that one container is able to serve 5 users, if for some reason at any point I need 30 users, that's 6 times the size. I can't, as a DevOps engineer, it is not ideal. It's not according to DevOps culture for you to go in manually and start creating more containers because you have more traffic, because you might not even be there by the time you have traffic. Let's say it's in the midnight, you're sleeping, and the traffic, for some reason, maybe you're running a campaign and you just see that more users are accessing that project or your site. So Docker containers as a concept, they are great, but they don't work on their own. They need to be part of something bigger, right? Something that enables them to be, what's it called? Let's say profitable to the project, that enables them to be very useful to the project. And that's where something like Kubernetes comes in, right? So if you're trying to think of an analogy that would help here. So with Kubernetes, you have the ability to orchestrate various Docker containers to behave in certain ways. And so you're able to define certain features that would deliver that scalability I'm talking about, that availability I'm talking about. All right, with Kubernetes, you're able to um, create objects that would enable Docker containers to automatically, for instance, automatically increase from 1 to 5 when, or 1 to 6 when the users increase from 5 to 30. It will increase as the traffic increases, it will decrease as the traffic decreases. So your ability to respond to traffic is very key, of course, in any application that you're serving. And Kubernetes that's just one of the things it does, and it's able to orchestrate this. Think about it this way. You can have, let's say uh, let's say you are a singer now. You have the ability to sing, and that is great. On your own, you sing fine, but there's a difference between you singing on your own and there's a difference between singing on your own and being in an orchestra, right? Singing on your own, there's only so much of an audience you can reach, let me say. But if you are with an orchestra, right, there are so many things you offer with an orchestra. You offer different parts. You even have like what we'll call, I've forgotten the name, but let's just say an orchestrator. You have someone that is the master that is directing everybody on how to sing. Imagine if as one person you try to sing all the parts of everybody in the orchestra. It doesn't make sense. It's going to be very difficult. So Docker is just like an engine. It can work, but you need some sort of orchestration to really take full advantage of that engine. right? Docker in this case can be like an engine in a car, but the 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 steering wheel, the gears, and all these things, they are what make use of the power in that engine to really make that car functional. To drive that, like when I say functional, I mean to utilize the power of that engine, right? So that's where Kubernetes comes in. Kubernetes is able to utilize the power of that Docker engine in a way that it's able to power applications at a very high level, very scalable, very elastic, adaptable, highly available, right? Because when you're running a Docker container in isolation, right, it has no availability in a sense, because if if the server you're running that Docker container on crashes or something goes wrong with it, your service is down. Or if you're running Kubernetes, which can be run in a clustered state, that means multiple machines coming together to act as one. If one of the machines go down, they crash, or there's an issue with it, you would not even notice with Kubernetes, because there are other machines that will pick it up. And with Kubernetes, you have already defined, there's something called desired state. I think I mentioned that last week. You have desired state and you have actual state. So you're not able to do that with Docker, but you're able to do that with Kubernetes. You're able to set a desired state. That means this is at every point in time, this is what I want my cluster to look like. I always want my cluster to have 3 nodes, maybe 6 pods or containers. And if traffic increases, this is just an example. Let's say you can define something like, if the average CPU of all the nodes increase, or they get to, let's say, 60 or 70%, I want you to add another node, and I want you to add 2 more containers. That means you are saying that if the CPU usage gets to a certain percentage, you know that the nodes are being overworked. Hence, you want to be able to add another node to reduce the load so that they don't all crash. So that is where auto scaling comes in. And all these things, you are able to do them with Kubernetes. You mentioned load balancing. That is something you are not able to do on just Docker. But with Kubernetes, you're able to do that because they have services that provide load balancers. And finally, round up your question. A lot of what you're asking, to be honest, is what we are going to learn today, right? So I think you would enjoy the class. There are a few things here that build on everything that we've learned with Docker, right? So everything kind of works hand in hand, right? Docker and containers is just a platform for you to learn about Kubernetes, even though you can use Docker and all that on their own. But with Kubernetes, it just utilizes the full power of it. I hope I've been able to give you like a sense of the
Yeah, yeah.
potential.
I'm okay. I'm
Okay.
very well. I'm good now.
Okay.
Thank
Okay.
you.
All right. Cool. You're welcome. But I'm sure you will still talk about some of those things here as we proceed. So we'll get a better understanding. All right. Cool. Thanks for that question. So we're rounding up. This is the last class in the foundation track, right? We've gone through a lot of things, and container orchestration with Kubernetes, of course, is the last module, but today's class is the last round. I want to congratulate all of you for getting this far. And we're just going to round it up with Kubernetes objects. Now, I want you to keep in mind that this is a foundation class. It's not an advanced class. So the aim is for you to have a reasonable understanding of these concepts and how to navigate them. Because as any software, as you would notice with any software, there are always so many pieces to them. and you learn about a lot of them as you progress in your use of them, right? So as you can see on the screen, we have Kubernetes objects, and everything you are seeing here is not even, it's not an exhaustive list, right? It's just a snapshot of some of the Kubernetes objects. So we're going to talk about some of them, the foundational ones, the important ones, the ones that you use day to day. Some of these are very niche. You might never use if your company or your project does not have that use case. But we'll talk about the ones that use very frequently. So the first are pods, right? So in Kubernetes, we have the concept of pods. And I say concept because pods have, they comprise of containers. And this is usually the part that is maybe most confusing for a lot of people, but I just want you to follow me because it's quite easy for people to mistake containers and pods and think they are the same thing, but they are not, right? Pods are the smallest and most basic deployable objects in Kubernetes, right? That means it's the smallest object that you can deploy on Kubernetes, right? It doesn't mean that it is smaller than a container. It just means that you can't deploy a container directly on Kubernetes. I think that's the point there. So a pod is the smallest deployable object. A pod is like a group of, let me say, a group of co-workers that share space. They share resources. They're able to communicate easily. In the case of pods, they contain containers, right? As you can see in this diagram here, a pod is made up of containers that exist within kind of the same group, right? Like a group of containers that share things like storage, network, a life cycle. I'll talk about each of those things. Right. So a pod can contain one or multiple containers that need to work closely together. The containers are always co-located. They're always in the same place. They're always on the same node. They're always created at the same time, right? So when a pod is defined, it's defined to have certain, oh, I think my sharing has gone off. Okay, sorry, just give me a second. Let me fix that. Okay, great. I think you should be able to see it now. Oh, I missed Bolaji's question. It says, so Kubernetes is more like an enterprise level of Docker. I would say it's more feature rich than Docker. Some companies use just Docker, but I mean, to a large extent, you're correct. It's more like an enterprise level. Docker's work is not to be like Kubernetes. So that's why I'm hesitant to say it's an enterprise level. Docker does its work. Docker's work is to be a container engine. Kubernetes is not a container engine. It's a container orchestrator. So they are like two different things. So it's not like level one, level two, right? They are two different things that work together, right? So the the brain and the body, they are two different things. You can see Kubernetes as the brain. We can see Docker as maybe the body, in a simple way, right? So they are two different things. Just to clarify on that. Okay. So like I was mentioning, pods are groups of containers, right? Pod is a group of containers. Some of the characteristics of pods are that they share resources. So all containers in a pod share the same network IP, port space, and storage, right? Which we call volume mount. So it allows them to communicate with each other using local host. That means they can speak to each other without having to, um, you know, go to various IP addresses. Localhost, as you know, is 127.0.0.1. If you're not aware, localhost just means that the local network of a device. So they talk to each other on the local network. It's just like, I'm in the room with someone here. I don't need to make a phone call. I don't need to know the person's phone number to speak with them because they're in the same room with me. So that's how containers are. Containers don't need to know, the IP address of the pod even to speak to each other because they are in the same space. So they have shared resources, right? They also share, they share network namespace, as we said. They share specification. So when a pod is defined, and we'll see that in the demo, when a pod is defined, it is, when it's defined and created, the definition usually holds maybe things like how much memory, how much CPU, how much storage, what network IP, different configuration. Now that configuration, uh, when the pod is created, every container basically has that same configuration, that has been defined for that pod, right? So if the pod has been given an IP of 192.168.1.5 or something, the pods would answer, sorry, the containers in that pod would answer on that IP, right? But in Kubernetes, you don't really talk about containers, you talk about pods, because like I mentioned, pods are the smallest, most basic deployable objects in Kubernetes. Now, some of the other characteristics of pods is that they share a life cycle, right? Pods are ephemeral in nature. And what that means is that they don't usually last for long. You don't expect a pod to be up for days or hours or or months or weeks. Like they will be created and destroyed and created and destroyed and created. They can they should be able to, easily transition from being created to destroyed and another one created, if that makes sense, right? Pods are created and deleted to match the state of your application as it scales up or down. So if your application requires 2 pods, they should be able to be created. If it's at some point requires just 1 pod, it will delete, one of the pods and have just 1 pod. And that should not affect the stability of your application, right? And Kubernetes handles all this in the background. That's why I said they share a life cycle. Life cycle just speaks of the time between its creation and its deletion. So if the pod is created, all the containers are created. If the pod is deleted, all the containers are deleted, as basically how it works, right? So pods are usually managed by higher level Kubernetes resources like deployment or replica sets. Now, we've not talked about these two, but we'll talk about them in the coming slides. So I want you to know that you'll probably not be creating pods directly. Let me put that caveat, directly. You'll be creating pods, but you'll be creating them as part of a different resource. Now, don't get confused. Don't worry. I'll explain that as we go, right? But you might not be creating pods directly frequently. It's just the way Kubernetes is set up. And you get it when we get there, and you see why that is the case. right? So some other things to note, right, in application deployments is that pods serve as foundational building blocks for Kubernetes application deployments, right? Of course, they have your applications runtime environment. We've talked about that in the past. When your application needs to scale, Kubernetes doesn't scale individual containers, but rather it scales pods, right? And containers within a pod can communicate with each other without the need to use IP addresses and all those kind of things, which increases their efficiency, right? Kubernetes schedules pods onto nodes based on resource availability, right? So if a node has enough resources to run a pod, to schedule it, so it ensures that each pod has enough resources to run its containers effectively, right? And while also, balancing the load across all other cluster nodes, right? So again, containers are the ones doing the work within the pod. The pod is just a group. It's just like a shell. It's just like, yeah, I think a shell is basically the best way to describe it. That has other things inside, right? In Kubernetes, the pod is an atomic unit of scaling. This means that you need, when you need more capacity, more pods are added, not just containers, right? And while pods are ephemeral, like I mentioned, they can be exposed consistently as a service, which we would also talk about, right? So the understanding of pods really and how they work is crucial to effectively using Kubernetes, right? Because it's linked to every other service that you run on Kubernetes. Um, Pods basically exemplify the principle of having tightly coupled resource sharing components in a portable environment. That means um, you want to be effective in your resource usage as possible, as much as possible when running your applications. And pods simplify that, the fact that they're able to bring, resources together to be shared among containers, makes it very effective, like an effective concept. That's what I'm trying to say, right? Now, we've talked about containers in the past, so I won't spend too much time on this because we understand that a container is a lightweight, standalone, and contains executable software packages, right? They encapsulate everything you need to run your software: code, runtime, libraries, environment variables, configuration files, and all those kind of things, right? Containers ensure consistency and efficiency when deployed across the diverse environment. So it doesn't matter what the configuration of the server is in the different environments. A container is always going to be a container. The way it has been defined to be is always the way to run on every environment, be it Windows, Linux, Mac, or whatever operating system, right? Now, I just want to talk about some differences between pods and containers, just to kind of hit the nail on the head and deepen into the understanding that we have, right? So containers are the smallest deployable units in any container orchestration system, right? Basically, outside of Kubernetes, right? Containers are the smallest deployable units, right? But a pod is the smallest and simplest deployable units within the Kubernetes object model. So within Kubernetes resources and objects that it defines, you wouldn't find a container there, you'll find a pod. But underneath, it uses a container, right? So we'd say containers overall are the smallest, but within the context of Kubernetes, pods are the smallest. I hope that makes sense, right? So a container is, it consists of the different resources that you need to run your application in terms of code, runtime, libraries, and all that. And a pod basically just contains one or more containers, right, that share resources. Now, in terms of use cases, I think I've mentioned some of the things I would love to talk about here. Okay, so one of them is management. Now, when you think about management of these resources, of containers and of pods, containers are managed by defining their properties in the container image. We've talked about that, like the Docker file and the Docker image, right? Containers are typically not aware of other containers except you explicitly configure them, right? To say, oh, you should share this thing, this container. If you don't explicitly configure it, container is not going to be aware that any other thing is running alongside. But in pods, pods, of course, are aware of the multiple containers that are running in that environment. They are aware of other pods too that are running, right? So that's a difference there. Kubernetes, in this case, manages the pods rather than individual containers. So rather than in the case of containers where you define, their properties, and that's how they are managed. In this case, Kubernetes is the one that manages those pods and basically just simplifies deployment and management of containers within pod. So we've talked about the life cycle. Containers have a life cycle independent of each other. But pods, on the other hand, they just have a single life cycle. Right? If a pod is deleted, all the containers within the pod is also deleted. Pod is created, all the containers are created. So these are just some differences between them. So I hope that has brought some clarity as to the differences between pods and containers and how they work. So we'll just move on to another resource. This is one of the most important resources in Kubernetes as a whole. It's called the deployment. So a deployment is a resource object that provides declarative updates to applications, right? A deployment to Kubernetes is like a higher level resource. It manages the deployment and scaling of a set of pods. That's the easy way to say it, right? A deployment is a resource that manages the deployment and the scaling, or we can say the creation, deletion, management, and scaling of set pods. So one thing you need to also keep in mind, or you need to understand, is within containerization, the aim usually is to have what we call microservices, right? Resources and services that are very small, like broken down into their smallest units, and they can work together, or they can be part of something bigger to achieve a goal. That's the major concept. That's why you see here that we talked about containers, and I'm telling you that containers are part of a pod. But now we're talking about pods, and I'm telling you that a pod is part of a deployment. So each of them work as building blocks for the next thing. So the next thing usually has, a feature that utilizes maybe the last thing and just provides a better service overall. And, we'll get into what deployment does, and you see why it is better to use that than to just use a pod only. So like I mentioned, it manages the deployment, manages the deployment and scaling of a set of pods. And you can think about it like, um, let's say a project manager who not only oversees the work that all the staff are doing, but ensures, that the project outcomes always match the planned objectives, right? So the reason why we say it's declarative, as you can see in the slide here, means that for a deployment, you declare what you want to be in that deployment. That means you declare the number of pods you want in their deployment, you declare the IP address, you declare several things in that deployment. And what Kubernetes will do is to take that and create the resources to match that declaration that you have made, right? In Docker, we had a Docker file, but in Kubernetes, we have a Kubernetes, configuration file, call them config files, right? And we'll do some of that in the demos, right? So in declarative, I'll just speak a bit about declarative management, or when we say declarative updates, just speak a bit more about what that means, right? So in declarative management, one thing you should think about is states, which I talked about last time, desired states and actual state. Just a reminder, actual state is the state of things now. Desired state is what you want things to look like, right? Even though it's like having the ideal and having the actual, right? The ideal thing I want is this, but the actual thing is what exists right now. So when you create a deployment, you don't just launch pods or containers, right? You describe the desired state of your application in a YAML or JSON file. YAML, that is YAML, or JSON, that is JSON. So these are just languages, right? That you use to define, the configuration for the deployment, right? You specify the container image you want to use for that deployment. You specify the number of replicas you want. That means number of pods you want, basically, and how updates should be handled in that deployment. Right. Deployments provide a convenient way to handle rolling updates, rollbacks, and they ensure high availability. Right. When you're working in the DevOps space, you don't only think of creating things. You always have to think of, what if something goes wrong, right? What if I created something and it's not working well? Maybe it has a bug or something. How do I roll back, right? Then you have to think of rollbacks. You have to think of updates. You have to think in this way. Okay, I've created this thing, but this would not be the best version of this thing, because I might have new ideas in the future, and I might want to update this let's say setup that I have, right? Um, that's where rolling updates come in for deployment. Rolling updates just means that you are able to update your pods without any downtime, basically, right? Let's say you have a new version, you are running version 1 of your application on your pods. Now you have version 2. How do I update those pods to run version 2? Oh, I've released version 2. Version 2 has a bug or something. How do I roll back that change? How do I change it back to version 1? Deployments are able to do this very, very easily. You're able to, write the configuration to ensure that this happens, right? One of the key things about deployment also is that it provides high availability, right? So it does this by ensuring, or by managing multiple replicas. Replicas just means the number of pods that you want. That's just what a replica is. So if you say you want 3 replicas, it means you want 3 pods in a deployment, right? So it manages the multiple replicas of your application, and deployments help ensure that your application remains available to users even if some pods fail. So you have to always think of that scenario. What if something goes wrong? What if a pod fails? What is going to happen, right? So deployments, they address the main goal of an application, of a DevOps engineer, let me just say, which is to ensure that whatever application you are hosting is always available to the users. You can build the most beautiful thing, but if it's not available to the users, if the users can't use it, then it's useless, basically. It might be the most beautiful thing, but it's useless to them. So if some pods fail, deployments have the ability to replace those pods. If you define that you should have 3 pods and one fails at some point and you're having to immediately start to create another pod, you don't need to do anything. It knows that it should be 3 pods, right? The other thing is load balancing. Kubernetes automatically distributes incoming traffic to pods of a deployment, ensuring that no pods become a bottleneck, maybe because there's too much traffic on that pod, right? And within the DevOps, let me say, culture, right? Or the use cases you have for deployments in DevOps. One of the things that it helps you to do is to enable continuous deployments, right? Deployments, that's Kubernetes deployments. Now, I know it might be confusing because I'm saying deployments and deployments in the same sentence. Deployments in plural, that's Kubernetes deployments. They are ideal for implementing continuous deployment practices. That's the DevOps practice, right? It allows you to seamlessly and safely deploy new versions of applications, test them in production, and roll them back if you have any issues, right? Because you're going to define a rollback strategy, you're going to define a rolling update strategy. So you might tell it, for example, I want you to deploy version 1. Maybe version 1 is running. You say, okay, I want you to deploy version 2 on this other node as a deployment. So you can test version 2. If version 2 works fine, you can then deploy it all over. But if it doesn't work fine, you roll it back, then deploy version 1 back, those kind of things. They also help in the DevOps, framework, helps in experimentation and testing. You can use deployment for experimentation and testing, right? You can do things like A/B test. If you've not heard about that before, A/B test just means that, I think it's really just what I said now. You have version A, you have version B, and you are testing them at the same time, putting traffic to both of them to see what the results are on both of them. If one works better than the other, and to decide if you want to stick with one or stick with the other, right? So they can help you easily test some of your changes before making them available to everyone, right? So again, deployments are very key to effectively managing containerized environments in Kubernetes, because you want to have that ability to make your containers highly available, load balance, scalable, rollout updates and rollbacks and all those kind of things. Right. So I'll just pause here. I know I've mentioned a lot of new things to you guys that you might not have heard of before. but I'll pause here to take some questions before we move on. So please, if anyone has any questions, yeah. If anyone has any questions, please just show with a raise of hand. Even if you didn't understand what I said, you have a specific question, maybe don't still get the difference between pods and containers, don't understand what the deployment is, just let me know. Just raise your hand and ask. Also, if you understood everything I said, please let me know, put it in the chat. Just let me know it's understood so that I have a good idea of what to do for the class. Okay, Namdi, please go ahead.
Hello, can you hear me?
Yes.
I still have a confusion
Okay.
phonetics and with the Dockers, the major difference between the two of them are like I'm still very much confused about it. I don't think there's a way you can do like explain something.
Okay. So you're confused between the difference between Kubernetes and Docker. Is that correct?
Yes.
From your understanding, what would you say you understand Docker to be right now?
I would say probably like is a bigger version of phonetics. That's where I kind of understand it, like a bigger version, and where Kubernetes has primarily maybe like a smaller version that handles specific tasks or something. That's what's coming to my head. So I don't know if I'm correct or.
Okay. So Docker itself, maybe I'll speak in technical terms first before maybe trying to give an analogy. In simple terms, Docker is a container engine. And what that means is that it's an engine for creating containers. That's what Docker is. Kubernetes is a container orchestrator. So it doesn't create containers, but it manages the life cycle of containers. It orchestrates their creation and their destruction, right? By giving instruction to Docker. So Docker works as part of Kubernetes, but Kubernetes, of course, is not part of Docker. Docker can run standalone, right? You would then ask the question, why don't you just use Docker alone? You can't just use Docker alone in certain situations. In some you can, depends, but Kubernetes provides a lot more features that you would need in achieving things like high availability, auto scaling, load balancing, and the likes. Kubernetes has those features, built in because it is a container orchestrator. So in managing the life cycle of containers through the container engine, which is Docker, it needs those features. But for Docker, it doesn't. Docker is just very simple. It's just like I create my container and that's it, right? Kubernetes is going to manage those containers across maybe even hundreds of servers. Docker, you can only run at the basic level, you can only run Docker on one server, except you're going to run, multiple versions of multiple instances of Dockers on different servers. which all of them will just be isolated. They won't be connected in any way. But Kubernetes can run containers on a cluster of servers, 100, 1,000 servers. And, it will manage all of them. You don't need to, do that work of management. You just define what you want. You say, I have 100 servers, need 5,000 containers. Kubernetes will figure out how to do that. But if you install Docker individually on multiple machines and you tell one of the machines that I need 5,000 containers, it can only do that on that one machine. And if the machine does not have that ability, it's not going to work, right? So that's the basic difference, I'll say. Think of Docker as a container engine, creates containers. Think of Kubernetes as a container manager or container orchestrator, right? It manages and orchestrates containers through Docker, using Docker. It gives that instruction to Docker. It's like Kubernetes is like Docker's boss, that is wiser than Docker. So it tells Docker, okay, work with me. These are the things I want you to do. It's like the when you run a business, for instance, and you have, let's say, you have a middleman in the business. Let's say you have a small business, then you have like a medium business, a middleman, then you have the customer, right? Let's say the customer wants something, the middleman has the wisdom, the know-how, and all that, but the smaller business maybe has the resources, right? Like can do the groundwork. So Kubernetes will take the request from the user and pass that information in a way that Docker can understand, tell it to create what it needs to create, and Kubernetes provides that to the user. That's just a very simple, of course, it's more complex than that. It's a very simple way. I think Bolaji also put it here. It says, one is an orchestration tool, and the other one is for containerization. Like that's a very basic, explanation I can give. And Namdi, does that help?
Yes, they are better.
Or is it still confusing? If it's still confusing, you can let me know. I know these things can sometimes be hard.
I'm pretty much better now. Like, pretty much
Okay. All right. All right. No worries then. You're welcome. Bolaji, please, you can go ahead. Bolaji, I think I've given you the ability to unmute. And go ahead with your question, contribution. Okay, maybe you can type in your question or your contribution, Bolaji. Because there's not much I can do from my end. You need to unmute from your end. Okay, thank you. Anyone with a question? Any other question? Before we proceed, do we have a question from Prosper or Raymond or Bobby, Nyalabuki, Manuel, Timothy, Henry, Noel, Lekon? Do you have questions from you guys or ladies? Okay, so I'm guessing no questions. Okay, thanks, Emmanuel. For letting me know. Okay, so Bolaji's question says the nodes and POSA. Could you let me know what POSA means? I'll do that well. Pods, I guess that's what they're trying to write. Okay, the nodes. Yeah, okay, I just got that. the nodes and pods, can they be in different regions of the world, like the model we have in Azure? Yeah, for sure. Remember that the pod is going to live on the node, right? So the nodes can be in various regions. But when you are going to be running Kubernetes, for instance, in Azure on AWS, typically you run it within one region, right? Like you run a cluster in the region, you can run another cluster in another region, right? I'm not sure, I don't think they run multi-region clusters, right? But it's definitely possible to run those nodes across different regions and interconnect them, by yourself, right? So I hope that answers your question about the posters. Just kidding, the pods. Okay, great. If that's all all the questions we have for now, hope we're really catching this. Of course, you can always rewatch this at any time, your own leisure time, and get more out of it. So we would proceed to speak about some different types of Kubernetes deployments, right? So you can define your deployments to work in different ways. There are different strategies that allow developers and operations teams to choose the best updates. So to choose the best approach for updates, testing, and risk management based on the specific requirements that they have. For instance, a team that has an SLA means a service level agreement. That means they are contractually obligated to provide a certain level of uptime, maybe 99.9% or something. That means maybe you're only allowed to have a downtime of maybe an hour in a month, just for example. Their deployment or update strategy has to be one that ensures that they meet that SLA. They can't be doing deployments strategies that allow them have downtime for 5 hours, like some of our banks in Nigeria do. They have to do deployment strategies that ensure that there's no downtime. But there are some, teams that have less stringent requirements. So what I'm trying to make is there are different types of Kubernetes deployments that fit the different requirements for different teams in its organization, right? So we have, number one, we have a rolling deployment. Rolling deployments is a gradual replacement of existing pods, in this case with a new version. It minimizes downtime and ensures a smooth transition, right? So in a rolling deployment, the old version is gradually replaced. The old version of an application is gradually replaced with the new version. In this case, it will happen one pod at a time, right? So let's say you had 5 pods. In a rolling deployment, it would um, it would add a new pod, then remove one pod. So to maintain 5 pods, right? So it will kill one pod, add a new pod. I think most times it will add the pod before it adds the new pod before it kills the old pod. So it will add the new pod, kill the old pod. So you still have 5 pods. You have 4 old ones, 1 new one. To do that again for one of the old ones, continue doing that until all the pods are new ones, right? So the advantages of this type of deployment, rolling deployment, is that it minimizes disruptions because only part of the system is updated at any time, right? Only a part of the system is updated at any time. and it ensures the service remains available and performant during the updates, right? Doesn't really have any disadvantage, to be honest. In this case, it's just a strategy that you use. Maybe the disadvantage is that it's slower. Okay, maybe we can call it that. It's slower for the deployments to go out because it does it one by one. All right. So Kubernetes manages the creation of new pods and the termination of old pods, ensuring that service availability is good throughout. Then we have blue-green deployments. Blue-green deployment might be the first time some of you are hearing of blue-green deployments. You know, for some, you might be familiar with it. In a blue-green deployment, it maintains two identical environments, directing traffic to one while deploying and validating the other one, allowing for a quick rollback if needed. All right. So in a blue-green deployment, you have two identical environments. One is blue, one is called blue, one is called green. So the blue is usually the one that is running. The green is usually the new one that you want to add. That's why it's called blue-green. It's just a very funny name. But yeah, blue is the active one. Green is the new version, right? So it's basically saying I'm switching from blue to green. But in this case, it doesn't do that add one, remove one, add one, remove one. No. What it does is it has both sets running at the same time. So if I had 5 pods and I wanted to deploy a new version 2 of my application, maybe I'm running version 1, 5 pods, it will deploy another 5 pods, making it 10 pods running at a time. Both of them are identical. Then what it would do is to test the new pods, the new version, the green one, to see if it's running fine, basically, right? It would to do some health checks on it. And once it's running fine, it will take the traffic that was directed to the blue and it will switch it to the green. It can be done instantly, right? And once it can confirm that, oh, the traffic is reaching the green, I'm sorry, it's reaching, yes, the green successfully, to then delete the blue one, right? And in this case, if it directs the traffic to the green and it's seeing that, oh, there are errors that I'm getting, to immediately redirect the traffic back to the blue. So it has to confirm that everything is fine on the green, like the health check has passed, the traffic is getting to it successfully before it decommissions the green, if not to roll it back, right? So this one is great. It has an advantage of being great at reducing downtime and risk, as it only involves switching traffic from one environment to another or one set of ports to another. And it's easy to just switch the traffic back if anything goes wrong. But as you can imagine, maybe a disadvantage, you can call it that, is that you need double the capacity when rolling out, because you need to, if you have 5 existing, you need to create 5 more, right? So you have double the capacity rolling out to be able to run a blue-green deployment. So this is a type of Kubernetes deployment. You also have the next one, a canary deployment. Canary involves introducing a new version to a subset of users or traffic to facilitate testing and monitoring before a full rollout. This is very interesting type of deployment. This type of deployment focuses on a subset of users, right, or servers. So what it does here is it would evaluate the new version's performance, the new version of an application, by first making it available to maybe a set of users. Let's say you had 10 users, right, accessing your application, and you want to do a canary deployment, right? So you deploy some new pods with the new version, then instead of moving all, even after you've done the health check, instead of moving all your traffic to the new pods, you just move small, maybe like 20% of your traffic. That means out of those 10 users, only 2 of the users, you allow them to access the new version while the remaining 8 access the old version. Then you test and see, oh, how is the performance doing? Is anybody complaining? Is it looking stable? Are we getting any errors? If everything is fine, then you move maybe the remaining sets of users that to that new version. So the deployment model here is more kind of focused on the users, right? Using the users to test if everything is working fine. Then the second to the last one on our list here is A/B testing. A/B testing involves deploying 2 or more versions of an application to see which performs better, right? You'll be simultaneously running different versions for a subset of users to compare performance and user experience in real world conditions. Unlike canary testing, which primarily focus on catching bugs, A/B testing is more about testing new features, right? Canary deployment is more like seeing, oh, is there a bug? Is there something wrong? Are the users experiencing any issues? A/B testing is more about seeing how the users enjoy the new feature you are deploying, right? So you are looking more, to get metrics about how users are using these new features and what their feedback is, right? So this kind of deployment allows teams to make more informed decisions based on the data collected from user interactions, all right? And it's very good for validating product decisions and enhancement. Based on the feedback you can get through, the data of user interactions, you can know if this feature would be useful to people. If you release the feature to them and you see that nobody is using it, it should give the team an indication that, yeah, nobody wants this and they can, retract it, right? Then the last type of deployment is rollback. Rollback is the process of reverting to a previous version of the application if the new deployment introduces issues, right? It enables swift and reliable reversal to a previous version, ensuring application stability. So Kubernetes supports quick rollback to a previous state, which is critical for maintaining service continuity and minimizing the impact of failed updates. Because as a DevOps engineer, you always have failed updates. It's not, it's impossible to not have failed updates, no matter how good you are, how perfect you are. There'll always be an issue that will come up at some point. So you have to always plan for an instance or a scenario where there will be an issue. You don't have the mentality that it will be perfect. You have to have, a sense of risk management to say, what if something goes wrong? How do we roll back, right? So the advantage of, the rollback deployment model is that it provides a safety net that ensures easy and quick correction of deployment errors, preserving your stability and availability of your application, right? So that's all for types of Kubernetes deployment. And the last thing we'll speak about before we go into the demo session, some question and answer, but then demo. We'll talk about services. Services is one of the other Kubernetes resources, right? I know some of the names might sound a bit generic. It's like deployment, services. These are things that you use in tech all the time. Why are they using them in Kubernetes? Well, I don't know. They just chose to use this name for different resources, right? So in Kubernetes, a service serves as a virtual front door for a group of applications. It ensures a reliable way for different parts of your application to find and interact with each other, no matter where they run in the cluster. Think of it like an organized and convenient way for different pieces of applications to connect and collaborate smoothly. So services, how can I explain this now? Okay, so when you are in an office and you have this intercom, these phone lines that everybody has their, I've forgotten what they call it. Everybody basically has their numbers, right? Maybe, let's see who is online. Maybe we have Eniola is on maybe 1011. Then Prosper is on 1021. Timothy is on 1031. Like we have our numbers that we can call each other on. It's not necessarily phone numbers, it's just like your intercom or landline or whatever number within that company. So all the phones are interconnected. And if I pick up the phone at my desk and I call 1011, it will ring on in your last desk. And I can pass a message across to Eniola because Eniola is able to communicate with me through those phone lines. So that's how services are. Services, they allow communication between different resources in Kubernetes. And primarily, the main communication is between different ports, right? In a very consistent way, right? So if you wanted to, let me make it simpler. I'm sure some of us are more familiar with this example. You have what you call dynamic IPs and static IPs, right? Dynamic IPs, that's a situation where you create a server or something and it's based on the DHCP server. It just assigns an IP to it, like a fresh IP every time. So today you create the IP is 192.168.1.2. You create it tomorrow, it's 192.168.1.5. Like it's a random thing, basically, based on the IP available. But you have what you call static IP. That is when you set a certain IP address on a particular server. If you destroy it and recreate it, it will still have exactly the same IP, right? So what services do is that they enable things like pods to have a consistent way to communicate with each other by assigning a permanent IP address and port to that server. So to that pod. So with a service, you can assign an IP and a port to that port so that if pod 1 wants to talk to pod 2, it knows the IP to use, exactly what IP to use, because it's static, right, on each of them. So it prevents the need to have like a very complex network architecture, right, where the IPs are unknown for different resources for different ports. So some of the key points here, we just talk through that. Unified communication, right? A service acts as a bridge, allows components to communicate seamlessly. I mentioned that. Consistency and reliability, right? That means, that just speaks of the IP address I said. That means every single time you try to communicate, you can communicate in a reliable way, in a way that you can predict. It's predictable because it will have a permanent IP and a port number that you know how to reach it, right? And location agnostic means that it doesn't matter what node it is on the cluster, right? It is able to communicate on that IP that you have given it, regardless of wherever it is, because you might have like 1,000 nodes or whatever. But as far as you've given it that IP, you'll be able to reach it on that particular IP. So that is one key function, or those are some of the key functions of services. One of the other things a service is able to do is it's able to distribute incoming network traffic across all pods that meet a certain criteria, which we'll get to, right? So it's services basically are load balancers in Kubernetes. That's a simple way of saying it. If you want to create a load balancer in Kubernetes, you're going to create a service, right? If you don't want that service to be a load balancer, usually it should be something called a cluster IP, which is the permanent IP address. Just means static IP, right? But if you want it to be a load balancer, you configure a service as a load balancer. I will do some of that in the demo, so you see what I mean. So we have basically 4 types of services. Some might say 3, but I'll just mention them quickly. We still have a slide for that, but I'll just mention them since we're here. We have the cluster IP, we have node ports, we have load balancer, and external name. Let's quickly see some of these, right? So the cluster IP is the default Kubernetes service type. So if you create a service and you don't give it any sort of configuration, by default, it will create a cluster IP for you. And all a cluster IP does is to expose the service on an internal IP and port number, to in the cluster, making it reachable from within the cluster. So it's kind of like a local static IP. And the scenarios where you will use this is where maybe you have a database or like an internal API that only needs to be accessed within the cluster, but not externally, not from external clients or users. So maybe it's just the pods that need to access a database or something that it's not external. It's like giving it a virtual IP address within the cluster, right? So that it can communicate with other things, maybe like front end, communicate with back, kind of thing. Then the other one you have is a node port. A node port exposes the service on a static port on each node's IP address. Now, when we talked about cluster IP, remember the cluster IP is for the port, right? Now, let's go back to the node. Each node has its own IP address. We've not talked about that because we don't really use that to do much in Kubernetes, except when we come to node ports. So each node has its IP address, right? And sometimes you might want to access the service on a certain pod, and I'll give you the use case here. It's most times you don't use it in production environments, really. It's most times in development, environment where you want to directly access a service from maybe the internet without using a load balancer or something, right? Sometimes you can use the node's IP address if it's public, right? You can use its IP address, but using a node port, you will expose a certain port number on the node's IP address, so that you can access an application or maybe a port or something. So that's the difference. Cluster IP is an IP address attached to a pod. Node port is a port on the node's IP address, right? So those are 2 different things. So you don't, get confused with that. Then the other one is load balancer that I mentioned, right? A load balancer automatically provisions an external load balancer and assigns a unique external IP to that service. It's useful for exposing services to the internet. So load balancers would usually have integrations with cloud providers, right? And what I mean is when you are running your Kubernetes environment, if you're going to use a load balancer, you would usually need to connect your Kubernetes to the cloud environment, let's say AWS, so that when you create a load balancer on your Kubernetes environment, at the back end, what it will do is it will go to AWS and create a load balancer there, get all the IPs, domain name, and all that, and come and use that within your Kubernetes application, right? So if you are running something like Elastic Kubernetes Service for AWS, if you create a load balancer Kubernetes service, what it will do is create a real load balancer on AWS. If you are running Azure Kubernetes service also, likewise, if you create a load balancer Kubernetes service within your cluster, it will create one externally, then use the details of that within your environment, right? That's the norm of how it works. Basically, just gives you an external IP for you to access your application. So it's ideal for production environments where you need to expose your applications to the internet reliably, right? And it handles large volumes of traffic. So the service that you use depends on your requirements, right? Um, if you need something just for testing, you can use a node pod. If you need something that is internal, just to give your pod an IP address and communicate with each other, use a cluster IP. If you need something to expose your application externally and to load balance traffic, you use the load balance Kubernetes service, right? So all these are needed, but in different scenarios, right? So I hope that kind of gives us an idea of the different Kubernetes services, different types of Kubernetes services. So I'll just try to get our questions once again before I go into the demo session where we'll create some deployments and some services. So do you have any question based on what I've said in terms of the services, the different types of services, and the types of deployments, all that? Does anyone have any question? I think you are speaking, but I can't hear you.
Oh, hello.
Okay, I can hear you now.
Very good. Yeah. So this port, I'm trying to figure it out in my head. This port that you're enabling, you're allowing,
isn't node ports?
The node ports, yes. Are they specific? Like in generally in IT terms, you say okay, one application is not going on the server. You say you allow the ports like HTTP, HTTPS, port 8080, 443. Does these node ports, do they have specific, or how do you identify them? In the general infrastructure thing, it's identified with numbers. But this one, how do you identify the node ports? Is it with numbers or do they
it's
have
also
names?
numbers.
Okay, numbers.
So the node ports, by default, when you create a node port, Kubernetes will allocate a port within a configured range, and that range is from 30,000 to 32,776. But of course, you can just define your own node port as you would like, right? And of course, the fact that it is like such a high number port, like 30,000 and all that, it shows that it's not really something for production. It's more for testing, like you just quickly want to test something. So you want to test the application on a port, right? So this port, it doesn't matter what the application's standard port is. I mean, when you create a service, you will tell it's kind of like port forwarding in a sense, but not exactly. You say, okay, the service should listen this node port, but at the back end, you would say that service should also pass the traffic to this port, this port. I don't know if you get, so you define maybe 30,001 then you in your definition for the pod, you can define 88 if that's what it needs, right? So I don't know if that gives a
Okay.
better idea.
It's like
Yeah,
port forwarding. Okay.
yeah, in a sense, yeah.
Okay. All right. Thank you.
All right, you're welcome. Okay, so do we have any other question before we dive into the demo? Okay, if none, then we'll just go into the demo and see how that works. So let's see. So in the demo, the last time we did a demo, we were able to install Minikube, right? Oh, maybe it's -e. Just want to see the okay. Maybe it doesn't have a version argument. But we're able to install Minikube. Let me see if it has like a status command. Okay, so everything is stopped here. Control plane and all that. So I'll just do a Minikube help just to see the commands. Okay, so we can use Minikube start here, right? Which is cool. I'll play the screen just to Minikube. Okay, so it's starting. So what we'll be doing here is to create a deployment, create a service, and maybe also create a pod, just so we can see what all these things look like. And I will show us what the configuration looks like for creating a deployment and explain everything that is in that configuration file, like one by one. But here we'll just wait for Minikube to start. So it's using Docker in the background, right? So I have Docker running here. You can see it on my screen. Because I mean, like we've explained, Docker is the container engine. Kubernetes is just the orchestrator, so it would always need Docker to run. Okay, Minikube is running. So I can do Minikube status. All right, so we see that everything is running there. Cool. Again, Minikube is not the way you run in production. Minikube is just something more for testing. It's a single node Kubernetes cluster, right? For you to just test and have a feel of how some of these things work. So what I'm going to do is I would, let me just create a directory called k8s or Kubernetes for full. So I'll cd here. This is not necessary, but I just want to have a clean space for us to do this. So I don't have any files here. So great. So we'll create a deployment, right? We'll create a configuration for a deployment. We'll create something called nginx deployment.yaml, right? So what I'll do is I'll paste this file rather than writing it one by one for the sake of time, and I would explain, right? So let me do this here. So this is the configuration file. This, if you wanted to create a deployment, this is the kind of configuration you write. So this configuration is written in YAML, and the way YAML works is it respects spaces a lot, right? Oh, okay. My sharing has gone off again. Sorry, give me a second. Let me fix that. All right, you should see my screen shortly. Okay. Great. So I was explaining YAML. So in YAML, it respects spaces, like I said. So for instance, if we wrote API version as we did here, and we wrote this, and okay, no, let me use something like spec. As you can see, I'm sure you notice the spacing is a bit weird. Like there are 2 spaces here, 2 spaces here, 4 spaces here. So it uses 2 spaces or a tab to kind of create a hierarchy of configuration. So when you write spec here, if you want to write replicas, which is a sub configuration in spec, you would add 2 spaces like this, or just use, okay, no, my tab is not configured well. So you use 2 spaces, then you write replicas, right? Sorry, no, replications, replicas. Then you put 2 spaces again, selector. Then now you want to write match labels, because match labels is not under is not under spec, it's under selector. You put 4 this time instead of 2. So 2 first, and another 2, then match labels. Right. So that's basically the YAML format, but that's not really what we're here to learn. You just need to kind of understand its requirements in terms of the spacing to be able to write the configuration file. But we're going to talk about everything you see here, because like I said, this is what you need to run a deployment. So the first thing you can see here is API version. So before you write any Kubernetes configuration file, you need to put the API version, right? And this API version specifies the version of the Kubernetes API that you are using to create this Kubernetes object, right? So in this case, you have apps, apps/v1. Apps is the, I don't know why it's not highlighting, but apps is the API group, and v1 is the API version. So the Kubernetes API has different groups depending on what you're trying to create. But for a deployment, it falls under the API group called apps, right? And the API version is version 1. You'll most times be using version 1. These things rarely change. But you always need to specify the API version that you are using, because when you write this configuration file and you're trying to create, your object, it's going to send all this configuration to the API, and the API will be the one to create it for you. So you need to tell it what API version you are using. Right. So the next one, which is kind specifies the kind of Kubernetes resource you want to create. We've talked about different resources, pods, we've talked about services, we've talked about deployments. In this case, we are creating a deployment, right? So we are just telling Kubernetes, this is the kind of resource I want to create a deployment. Then next, we have metadata, right? So metadata, it provides basically metadata about the deployment, information about the deployment, things like labels and annotations, right? Because for instance, in this case now, one of the metadata is the name of the deployment. You might want to give it a name so that you can reference it in the future to differentiate it from other deployments that you do. This could have been Nginx deployment 1, Nginx deployment 2, or if this was not Nginx, if it was Apache, it would be Apache deployment. So metadata in this category of metadata, you just define the different metadata about that deployment, and name is one of them. So you just put the name, and you put the name of the deployment you want here. This is totally dependent on you, right? Whatever you want to put here is fine. Then we go down to spec. Spec is the most important part of this file. Everything else, well, spec and kind, to be honest, and the API version. Metadata is optional. You don't always need to put metadata, but you need to put the kind, you need to put the API version, and you need to put the spec, right? So the spec specifies the desired state of the deployments, which we have been talking about, desired state, right? It includes the settings for that deployment, like the number of replicas, the template you should use, the container image and all those kind of things, right? But spec has like a number of things under it now. One of them is replicas. Replicas specifies the desired number of pods that you want to be running at any given time. So Kubernetes will attempt to maintain, in this case now, based on our configuration, what this means is Kubernetes will attempt to maintain 2 pods at every given time, 2 pods for this particular container image, right? So if it's running 2 pods and you go and kill one, it would create that pod again, and I will demonstrate that shortly. Then the next one we have is selector here. Selector defines how the deployment finds which pods to manage. So in this case, it uses we're going to use a label selector to identify this, right? So the deployment needs to know when the pods are running, it needs to have a way of identifying, oh, which pods am I in charge of? Which pods am I supposed to manage? And in this case, we'll be using a label, right? We'll label those pods, give them a label. We'll give them a label called app engine X, and I'll explain this. So anytime it sees a container, a pod rather, with this label, it will know that it's in charge of that and it's supposed to manage that pod. So we're using match labels here. Match labels is a map of key value pairs that must be present on the pod for this deployment to manage that pod. So anything that has this label with this key and this value, this deployment to manage it. This is our Nginx deployment, right? Then the next one is templates. Template specifies a pod template that the replicas will use when they are creating new pods, right? Or when they are scaling up or recovering pods or something, they will use this template. Now, the metadata here, again, similar to this, but under the template, metadata just defines the metadata for the pods that will be created from this template. So this metadata up here is for the deployment, and this metadata here is for the pods. So they are 2 different things, right? Then the labels here just says that you want to create a type of metadata called label, and app and nginx is just, again, it's the key value pair, is the label you want to put on that pod so that it matches with what you put here. So these 2 always have to match. They match the selector and the labels here. They match labels here and labels here. So once they are the same thing, the deployment would be able to manage whatever pods are created from this template. And it's always a key value pair. So it's saying, oh, this is an app and the name is Nginx, basically, right? So under these templates, you now have spec again. This spec defines the specifications of the pods, right? Things like containers, volumes, other configurations that define how the pod should behave, right? Then container here just has a list of containers that should be included in this pod. In this case, we're going to include just one type of container, right? Even though there will be 2 pods, but just one type of container in that pod, right? So the name here is basically giving a name to the container, can be anything. The image here is the Docker image, the container image, whichever one you want to call it, or the Docker container image and its version that we want to use. So the name of the container image we want to use is Nginx, and its version is 1.14.2. Right? Hope that's clear. Then the ports here, basically what it does, it lists the network ports that the container exposes, right? Then the container port here specifies the ports that the container would expose. In this case is port 80, right? So this is a YAML file that we can use to create a deployment on Kubernetes, right? So what I'll do is I'll save this file here. First thing I'll do a kubectl. So kubectl, I think I spoke about this in the last class. It's kubectl is a command line to use in managing the resources on your Kubernetes environment, your Kubernetes cluster, right? So I'll do kubectl, and the way the command, I mean, the tool works is that you run kubectl, then you run an action, then you write an action, then you write the name of the resource you want to perform the action on, right? So let me do a help so that, you see some of those actions. So, so you have things like create. You see, they say these are beginner commands, right? These are intermediate commands. Then I think you might have some more advanced commands here. Yeah. So you have, let me just see if you have any questions, anybody in the chat. Okay, so I see Chike. Chike said, I can see the metadata name and Nginx deployment. You also made mention that it could be Apache deployment. I'm not familiar with the whole background of Kubernetes, so I ask if it applies to web server applications only in tech. Otherwise, which other metadata can be presented here? Chike, no, it doesn't apply to just web server. It can be anything. It can be MySQL deployments. It can be any sort of applications. I'm just using Nginx here because that's a very simple one to use as an example, right? And again, the metadata is anything you want to write. But of course, it only makes sense for it to be descriptive. I could have written a metadata of Wisdom's pod, but we wouldn't really know. It's not very descriptive, right? So Nginx deployment is just something descriptive. But again, it's not just web servers, it's anything. Web servers are usually used as the examples just because, it's easier to understand and it's not, very complex for one to test and to deploy, right? So yeah, thanks for that comment there. So what I'll do, what I want to see is I want to see the resources that we have. So I'll use the get here, right? Let me just clear the screen. So I'll say, oh, it didn't clear. So I'll say kubectl gets pods. So I see that some pods are running. And they've been running for quite a while. But these are the pods for the Kubernetes cluster itself, right? Not what we want to create. So we have written this file here called nginx deployment.yaml, and we want to deploy it. So how we'll deploy it is just by doing kubectl apply -f, which means file. You're specifying the file, then nginx deployment.yaml, right? So if I run this command now, what should happen is that it should create our deployment. So let me do that. Oh, you see, it's done. I didn't even expect it to be that fast, but it's done creating our deployment. So what we can do to check that that was successful is just do kubectl get deployment, right? So we can see that it's created our deployment and it's told us that up to date just means the desired state here. Available means the actual state here. The age just shows how long it's been running. So it says we have 0 out of 2 pods available in our deployment right now. That means it hasn't, I mean, it's created the deployment, but it's still spinning up the pods, right? So I can try again. Kubernetes, sorry, kubectl get deployments, and we see that, oh, we have 2 out of 2 now. So it's created it. So let's also check and see the pods. So we can see now that by creating this Nginx deployment, it automatically created these 2 pods, even though I didn't directly run any command to create these 2 pods. But because I specified that I wanted 2 pods, then it created it. Now, what I'm going to do is I'm going to try to kill, like destroy one of these pods, right? So I'll do kubectl delete pod. I'll delete this one here. I think there's a delete command. So it's deleted now. So let's do get pods again. You can see that it immediately created another one 4 seconds later. You see that the one I deleted is H9 WDR, but you see it's created another one called BQ JFR immediately. So why it did that is because we have a desired state of 2, right? And if I delete any one, or if any of them crashes, it will create another one to maintain that desired state, as I explained differently. So what we can also do is let's look at some of the kubectl commands that can help us. So we can, let's see. Okay, let's use describe. Describe will help us in this case now. So let's do a kubectl describe deployment and the next deployment. So what this does is basically give us some information about the Nginx deployment. So you can see now it's giving us things like the selector we described, we configured, giving us Nginx, the name of our deployment. It's telling us the strategy type. We talked about it. This one is rolling updates. We're using rolling update. That's what it uses by default. Then it shows us the number of desired replicas to the available ones, which is 2 also, the total number, different details here. So this is the rolling update strategy. At most 25% can be unavailable, and 25% max search. So this is just some information that can help you debug if something is wrong with your deployment. You would usually see the debugging information you need in this event. So if something went wrong, you see a type here that is not normal, maybe a type called error, then it will give you a message telling you what the error is, right? What happened, so you can easily know what's wrong. So you can see things like our container definition here and all this kind of things. So because we're running out of time, what I'll just do is for us to create a service, because I want us to also create a service before we go, right? We've created a deployment. We see how that works. Let's quickly write out the service to create. So let's create something like Nginx service this time, .yaml, right, rather than a deployment. So we'll see the difference. So the configuration file for a service looks like this, right? So for a service, we don't need to put, the apps v1 like we put in the last time. We'll put a kind called service here because we are creating a service now, not a deployment. We'll give it the metadata name, like we said. And in this case, we're going to create a node port service. A node port service. So the question came from, I think, Bolaji the last time. So this is what I say is like port forwarding, because here we are specifying the node ports, but this port here means that it's talking about the pods internally on the pods that traffic is going to be going to, right? And we've put a selector here, app nginx. We are saying all the nginx, all the pods with this selector here, with this label rather, sorry, would receive this traffic. So the traffic will come on this port on the node 30,007, then to be directed to this port 80 on the pod, right? So that's why I say it's like traffic forwarding, port forwarding in that sense, right? So it's a very simple, node port service here. So what we'll just do is to create this and see how that works. kubectl apply -f nginx service.yaml. So it's created. So we can, instead of doing kubectl get deployments, this time we'll do kubectl get service or services, whichever one you do would work. So we can see our nginx service here, and we can see that it has it's taking traffic on this and it's pointing into this, and it has an IP address, right? Which is different from the other ones. So so that's basically how to run, create your resources on Kubernetes, right? We can also create a pod, but it follows the same model. We'll just change the kind to a pod, we specify our containers and all those kind of things. But this is the basic way you create different services, different resources on Kubernetes, and you use your kubectl to manage those resources. So I recognize that our time has gone past. So I'll just check if we have any questions here. I'm sure this has kind of given us an idea so that we can go forward and like do some more practice. We have our capstone projects and all those things that would involve some of what I've talked about here. So we can also use that to really deepen our understanding of this topic. So do we have any questions on either the demo or anything else that I've spoken about here that I can speak to before we round up for today and for this foundation track? Any questions? Please feel free to ask, because this is our last class in the foundation track. So please don't be shy. Ask your questions. Emmanuel, go ahead, please.
Good evening, guys. And good evening,
Good evening.
Wisdom. Thank you so much for everything from the beginning of the class to this moment. Thank you. My question is not really on this course. It's just
Okay.
just a general broad question. Now that we are done with this beginner class, I want an a honest review from you. Will you suggest, if we have any, let's say, a project we can just jump on, or we should still spend more time trying to grasp these basics we are still on? What will you recommend?
So it depends on the complexity of the project, I would say. If the project is also a beginner project, why not? You can try your hands on it. But I would say you should try to, perfect what you have learned first, go over it. Depends on, how much time you've already spent on it, but go over it, try some projects on your own, think out scenarios that you want to do. Maybe, draw out something, or you want to create this kind of Kubernetes architecture, you want to create these services. And when you see that you're able to do these things very fluently, then yeah, sure, you can jump on a project. Again, depends on the timeline of that project and if it's, a beginner project. If someone is telling you that they want to create 100, Kubernetes servers, right? The Kubernetes cluster with 100 servers with various advanced features or something, and they need it in 3 days, you might not want to jump on that to not put too much pressure on yourself because you're still learning. But if you have like a smaller project which fits within the scope of your knowledge and you're learning right now, sure. The best way to learn is by doing, right? The best way to learn is by doing. Again, if that project even gives you time, you can jump on that project, and as you are trying to deploy it, you are also reading up, looking at docs, you are learning. The idea with learning, especially in tech, is not that you have every information that you would ever need. No, is that you have the basic concepts and you know where to find what you need. You know how to read documentation, you know how to get help from your command line, you know the core concepts of what you are doing, so you can build on your knowledge at any point to achieve the goal of whatever project you're working on. So I hope that answers your question.
Yeah, thank you so much.
Awesome. You're welcome. Chike, please go on. Ask a question.
Okay. Good evening, Wisdom.
Good evening.
Yes, I really must commend you for the so much work that we are witnesses to, as to the commitment, and of course, it's been a journey. I can remember we started in January, and
Yeah.
I know how many we were when we started. Today being the last day, I can see 11 people, and I think that shows the level of commitment for these people that are here.
Yeah.
Being here on the last day, it's most important for me in terms of moving forward from this foundation. This is a question I had waited maybe after this I could not ask, but I want to follow it up from what Emmanuel asked, because I personally have plans to make sure that I perfect what I've learned in this foundation before I would even want to move forward. So my question now is, when the continued class, when would it start? Because I really wish that we would be given time to finish up our projects. At least we need to finish up our projects, and then so we can follow up. It's important for me because you just introduced Kubernetes. So at the point that we might need to join the next class,
You
we
mean
will have.
the advanced one?
Yes, exactly.
Okay.
So at the time, it is critical for us, for me exactly, for the timing that we need to join the next class so that it becomes a continuum.
Okay.
You
Yeah.
understand?
Yes, I understand. Thanks so much for sharing that concern. I
Okay.
think our customer experience expert summer is not around, but it's not going to be immediate. That's one thing I'm sure of. You'll be given time to finish your projects and all those kind of things. And the next class, the starting time, of course, will be discussed with you. And if you have any objections, you can let them know. But I'm very certain it's not immediate because I also haven't been informed of the time yet. So I know that it is not immediate. So you're going to have the time to practice, to finish up your projects and do all those things. We're not rush feeding you here. The idea is for you to, to digest and understand and become a better, DevOps engineer before you move
Yeah.
on to the next thing. Yeah. So yeah.
Okay, in as much
I
as
hope
it's not
that's
going
all
to
right.
be immediate, in as much as it wouldn't be immediate, more like an appeal I'm making, that we have enough,
Okay.
because 2
Enough
months,
time. Yeah.
ordinarily we already are having 2 months to finish our project. And if we can get extra 1 month even before we can start, just having enough time to, yearn for the next stage.
Yeah.
I think it's something
I think
I'm
that's
asking.
fair. Yeah, I would definitely communicate that, to the customer experience team so that they take that into consideration when scheduling your next class. I think 1 month is definitely possible. But in this case, I'm just the instructor, so I'll pass that feedback, to them to schedule that. Yeah. Yeah.
Thank you
Thanks a
so much.
lot for sharing that concern. Yes. So as Chike said, I actually want to congratulate every single person that has made it this far. It is not an easy journey. It's been, like I said, since January. If you think of that, that's 5 months, that we've been on this journey of getting you from probably knowing nothing about DevOps or maybe having some little knowledge to at least being able to stand your ground in terms of various concepts in DevOps, being able to take on beginner projects, learn different things. I want to say it's a bold step that everyone has taken, and I think it's a great one in your journey to becoming a DevOps engineer. And I think my only advice to you right now would just be to continue to practice everything you've learned and go beyond it. Don't just stick with what you've learned here. There's so much information on the internet. Go beyond it, hone your skills, work practically on projects, watch videos. If you see any conferences that have to do with what we've learned here, also watch them, understand this concept, and to be honest, the sky would be a starting point for a lot of you. So thank you guys for the time. And I hope to see some of you in the advanced course if you decide to delve into that, where we'll go deeper into a lot of these topics that we've talked about. So I think we'll call it a day for today. Are you going to be given a certificate? Yes, I believe so. You'll be given a certificate that will be communicated to you. I think that's a question from Timothy. Yes, you'll be given a certificate. For this long period of time, you all deserve a certificate. So you'll be given one. So thank you, everyone. See, Timothy is typing. That's a question, but thank you all. Have a good evening. For anyone that wants to leave, you are free to leave right now. Have a good evening and see you soon. Yes, so Timothy, you can start applying to jobs for sure. You can start doing that. Yeah. All right. Take care. Bye.